All right, so today we're going to talk about radian measure and angles of rotation. The measure of an angle is determined by the amount of rotation from the initial side to the terminal side. We can measure the angle using degrees or radians. So the definition of a radian, one radian is the measure of the central angle, theta, created by bending the radius length around the arc of a circle. So notice this is the radius right here. That length is, of course, equal to this length because those are both radii, and that is also equal to this length right here. And so that arc length is equal to that angle measurement. So that's 1 radian. What if we were to rotate the radius length all the way around the circle, continuing to add radii lengths, we would find that it takes a little more than 6 of them to complete the rotation. So here we have the first one, this is the second, third, fourth, fifth, sixth. So that's the sixth length equal to the radius, I should say. And we have this little bit more that doesn't quite make it, which is actually 0.28 of a radius. So that means that it takes 6.28 radians to make a complete circle using a radian measure around our circle. So if we were to calculate 2 pi on our calculator, you would notice that if I hit 2 pi, I get 6.28 about. So notice that that measurement is the same for what it takes to go all the way around our circle with our radius. So it takes 6 and a little bit more, or about it takes 2 pi radians. So this means that a circle, which has 360 degrees, is equal to 2 pi radians. So now we can measure a circle not only in terms of the degrees, but now in terms of the radius. So we can use the 360 degrees equals 2 pi radians to help us convert from degrees to radians and radians to degrees. So if you think about it, if we know that 360 degrees is equal to 2 pi, well, if we want to figure out what 1 radian is, then we would have to divide both sides by 2 pi. So that would mean 360 degrees divided by 2, which is 180 over pi, is equal to 1 radian. And if we wanted to go the other way, 360 degrees equals 2 pi. If I wanted 1 degree, divide both sides by 360. And notice we get 1 degrees equal to pi over 180. So this is where we get our conversions to convert from, again, radians to degrees or degrees to radians. And make a note that no degree symbol means you are using a radian measure. So if it is a degree, then you need to make sure that you're always using the degree symbol. And whenever you're writing a radian measure, you want to leave the answer in simplified fraction form with pi. So we don't write the decimal when we're writing a radian measure. We're always going to leave our answers in terms of the lowest fraction with pi in it, which we'll look at in just a minute. So the formula to convert from radians to degrees is you multiply the degree measure by pi over 180. And again, that's because of this conversion right here. So if I look at question number 1, we want to convert each angle in degree measure to radian measure. So if we look at the first one, we have 500 degrees. So if I multiply this by pi over 180, that means we're doing 500 pi over 180. So we want to, again, reduce this, but always leave pi in your answer. So again, make sure to leave pi in your answer and that the fraction is in reduced form, no decimals. So if you need to use your calculator to help you, you could always plug this in. So I would plug it in without the pi. You could do 500 divided by 180 and hit the math fraction key if you don't know how to do that in your head. So you get 25 over 9, but then you just need to put the pi back in. So 25 pi over 9. Why don't you go ahead and pause the video and do the next 3 on your own, and when you're done, you can unpause to check your work. So if I want to convert 390 degrees, I multiply this by pi over 180. So that's 390 pi over 180. And when I reduce this, I end up getting 13 pi over 6. And we don't label radians like you do when you label degrees with degree symbol. So I just know these are radian measures because it doesn't have a degree symbol. So if I go ahead and again plug this in, we have 390 divided by 180, and you can hit the math fraction key to help simplify those fractions. So the next one we have to multiply again by pi over 180. So now I have negative 150 pi over 180. And when I reduce, I get negative 5 pi over 6. So this would be a negative radian measure. And negative 50 degrees, same thing, multiply by pi over 180. So this is negative 50 pi over 180. So when you reduce, you get negative 5 pi over 18. So those are the radian measures. Now we're going to go the other direction. We're going to convert from radians to degrees. So to do that, you're going to multiply the radian measure by 180 over pi. And again, that's because of this conversion right here. So for the first one, when we multiply by 180 over pi, notice that your pi's are going to cancel out, so that gives you 180 over 10. And for this, when you reduce, 180 divided by 10 is just 18 degrees because your zeros will cancel out. So 18 degrees, and make sure you put that degree symbol because that's the only way that we know it's a degree measure. So for the next one, if I multiply by again 180 divided by pi, I get 1,260 divided by 6, and your pi's of course cancel out. So when you divide that, that's 210 degrees. Go ahead and do the next two on your own. When you're done, you can unpause to check your work. So for the next one, if we multiply this by 180 over pi, we end up with canceling out the pi. So negative 14 times 180 is negative 2,520 divided by 15, which gives us negative 168 degrees. And for the last one, same thing, multiply by 180 divided by pi. Your pi's end up canceling out. So you get negative 4,140 divided by 10, which is negative 414 degrees. So for the next part, for question 3, it says label the following protractor in radians. You should label every 20 degrees from 0 to 180. So I did 0 and 20 for the examples for you. So why don't you go ahead and pause the video and do the 40, 60, 80, etc. all the way up to 180 on your own. When you're done, you can unpause the video to check your work. So for this next one, 40 degrees, you should have gotten that equal to 2 pi over 9 radians. For the next one, 60 degrees is equal to pi over 3 as a radian measure. 80 degrees, when you convert that, you get 4 pi over 9. 100 degrees becomes a radian measure of 5 pi over 9. 120 degrees is 2 pi over 3. 140 degrees is equal to 7 pi over 9. 160 degrees is equal to 8 pi over 9. And 180 degrees is equal to pi. which makes sense because if 360 degrees is equal to 2 pi, then of course if we take half of that, which is half of our circle, we get 180 degrees is equal to pi. So for question 4, it says use what you know about symmetry of a circle to label each central angle, measure in degrees and radians on the unit circle below. So for this, we know that if I were to go all the way around my circle, start here at 0, and we'll talk about why we start at the x-axis, but this is 0, and in order to get a positive angle measurement, you're always going to go counterclockwise, because remember this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So because we follow the quadrants for positive angle measurements, that's why you see it starts here at 0 and then 30, 45, 60. So if we think about the fact that all the way around our circle is 360 degrees, so we start at 0 and go to 360. If I do a fourth of the circle, of course, then we know up here would be 90 degrees. And then we know that half of a circle is 180 degrees. And so if this is 90 degrees and 90 plus 90 is 180 plus another 90 down here would give us 270 degrees. And then, of course, all the way around we said is 360 degrees. So if I were to go all the way around. So now let's see if we can do this with the other measurements that we have. So this is 30 degrees plus another 30 degrees. Notice gives us 60. So I'm using this angle measurement here. That angle measurement is the same as this one. So if I add another 30 to 60, I get 90, notice, which is the same as this angle measurement. That's another 30. So if I add another 30 degrees to that, I get 120 degrees. If I add another 30, that would be this angle measurement right here, which is 150 degrees. Go ahead and see if you can do the next part of the circle, quadrants 3 and 4. And then when you're done, pause the video to check your work. So if we add another 30 to 180, we get 210 degrees. If we add another 30 to that, we get 240 degrees. Another 30 is 270. Another 30 is 300. And another 30 would be 330 degrees. And of course, we can also do this with the 45 degree measure, which is this measurement right here. So this is 45 degrees. If I add another 45 to that, which would be from here to here, notice that gives us the 90. So we're going to keep on adding. So 45 plus 40, another 45 is 90. 90 plus 45 gives us 135 degrees. Plus another 45 is 180. Plus another 45 gives us 225 degrees. Plus another 45 is 270. Plus another 45 is 315 degrees, plus another 45 gets you back to the start, which is 360 degrees. Also notice that in between the 30 and the 45 are 15 degrees, so you could have counted by 15 from the other angle measurements that you had. So now that we have the degrees all the way around our circle, go ahead and pause the video and see if you can write your radian measures using our conversion, multiplying by pi over 180. So when you're done, pause the video to check your work. So looking at the next part, throw the radian measure. So if we start here at 0, this would be 0. Then 30 degrees converts to pi over 6. 45 degrees is pi over 4. Pi over 3. You should have gotten pi over 2 when converting. And again, so remember, I'm just going to show you again, we're taking the 30 degrees and multiplying it by pi over 180. So when you reduce, that's where you get the pi over 6. You should have done that for all of these. So the next one would be 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, and 11 pi over 6. And again, we were just using the conversion where you multiply by pi over 180. for that. So that gives us values on our what we call our unit circle, which we actually have a lesson on that, so we'll talk about that later. So let's go ahead and look at angles of rotation to, again, talk about why we started at the x-axis. So standard position for an angle of rotation, the vertex of the angle is at the origin, 0, 0, and the initial side is the positive x-axis. So this is initial side, this is where we start. So the initial ray, which is one side of the angle, on the positive x-axis. It's where you start, or where the angle starts. The terminal ray, the ray where the measure of the angle stops. So this can be anywhere. So if this is our starting ray and this is our terminal ray, then this measurement from here to here, which I'll call theta, that would be our terminal ray. So this is where we stop. And that gives us from here to here the angle measurement in which we have moved. So positive angles always go counterclockwise. And why do they go counterclockwise? Because they follow the quadrants. So again, this is quadrant 1, 2, 3, and 4. So that's why going that direction will give you a positive angle measurement starting with the x-axis. Negative angles are going to be rotating clockwise. And so if I was doing a negative angle measurement, I would start at the x-axis and go the other direction, this way. So the amount rotated is the measure of the angle, which we said above was theta. So this amount that was rotated was theta, which in this case would be a positive angle measurement. For this picture. If we would have went the other direction, it would have been a negative angle measurement. So let's go ahead and practice. So it says to draw each angle in standard form, determine the quadrant in which the terminal side lies. So 220 degrees. Think about what we just did on our unit circle above. This started at 0 degrees. Then we had 90 degrees plus another 90 is 180 degrees plus another 90 is 270 degrees, and all the way around is 360 degrees. So that means that 220 degrees would be in between 180 and 270, which means we are using quadrant 3. So for this, we can then draw our terminal side. And of course, 220 is 40 more than 180 degrees. So it's almost in the middle. So about right there is our terminal side. We always start at the x-axis. So from here to here, that would be 220 degrees. So this would be the angle drawn in standard position because we started at the x-axis and we rotated all the way around to the terminal side. So that would be how you would draw your angle. So if I look at the next one, question 2, we know this is 0 degrees and 90 degrees, so 60 to 7 degrees. We know it's going to be in this first quadrant and be somewhere up about there. So from our x-axis, which is our starting position, to here, we have 67 degrees. And again, notice I always draw an arrow for which direction my graph is moving from the x-axis. So from the x-axis, and again, we're going counterclockwise for positive angle measurements. So for the next one, we have a negative angle measurement. So if I have a negative angle measurement, I'm going the opposite direction on my circle. So I'm starting here at the x-axis at 0 degrees, but then I'm going the down instead of up first. So that means this is negative 90 degrees, negative 180 degrees, negative 270 degrees, and negative 360 degrees. We just went the other direction on our circle. So negative 25 degrees means their terminal side would be about here, start at the x-axis, and move to there. So that would be negative 25 degrees. If I want to graph 156 degrees, so again, we know this is 90 degrees and 180 degrees, so 156 we know is in quadrant 2. So that would be somewhere about here. And so we'd start at the x-axis, go counterclockwise, and stop here. And so that's for drawing our angles in standard position. Now we can do the same thing when we are looking at radian measures. So if you can't tell with a radian measure, you can always convert to degrees. So if I have pi over 15, to convert this to a degree, I multiply by 180 over pi. So your pi's cancel out. 180 divided by 15 gives us 12 degrees. So a pi over 15 is equal to 12 degrees, which we know is in quadrant 1, about somewhere there. So that would be my angle drawn in standard position. For pi over 5, if I multiply that by 180 divided by pi, pi's cancel out. This is 144 degrees, which we know is in quadrant 2. Somewhere about there. So from here to here gives us 144 degrees, or 4 pi over 5. And I should have done the radian measure here since that's what we were given. So for the next one, we have 8 pi over 7 times 180 over pi, which gives you about 205.7 degrees. This would be, of course, then in quadrant 3, because this is 180 degrees and 270 degrees is here. So if I draw my angle in standard position, would be here, so that would be 8 pi over 7. If I look at the next one, we have negative pi over 12. If I multiply this by 180 divided by pi, I get negative 15 degrees. So that means we would be in quadrant 4 because we're going the negative direction. So that would be negative pi over 12. You could also think about doing this using radians. So if you were to use radians, you know this would be 0 radians. If all the way around my circle is 2 pi, well, if you divide that by 4, 2 pi divided by 4 is pi over 2. So that means this is going by 1 pi over 2. 2 pi over 2 is pi, half your circle. 3 pi over 2 and 4 pi over 2 is all the way around, which is just 2 pi. So you could also think about the decimals, if that helps. So if I look at the first one, pi over 15, I could do pi divided by 15, and notice that that's 0.20. And if I look at pi divided by 2, I know that's 1.57. So that tells me, since this is about 1.57, that I have to be in quadrant 1. So I could do the same thing. Pi we know is about 3.14. So if I look at question number 6, if I do 4 pi and divide that by 5, notice I get 2.5 1, which tells me I'm in quadrant 2. I just have found over the years it's a lot easier just to have students put it in degrees and go from there, but again, you could also use that as a way to help you. So the next thing we're going to talk about is coterminal angles. So coterminal angles are angles with different degree measures that terminate in the same place. So that means that they have the same initial and terminal sides. So to find, you're going to add or subtract 360 degrees if you're in degrees, or if you're in radians, to pi, because that would go all the way around. So if I do the first one, let's do 120 degrees. So 120 degrees we know is in quadrants 2, about up here. So that's the angle drawn in standard position. If I want a coterminal angle with 120 degrees, I can add 360 degrees to that, which gives me 480 degrees. So if I wanted to draw 480 degrees, I know that the starting side and the ending side are the same. It just means I've gone all the way around my circle is 360 plus that 120 degrees gives me the 480 degrees. And I could keep doing that. Another coterminal angle, I would add another 360, and I could keep adding 360 in order to get coterminal angles. So what if I took 120 degrees and subtracted 360 degrees? I would get negative 240 degrees. So again, we still have the same initial and terminal side. It's just that we've gone this direction on our circle. So negative 240 degrees. So 480, negative 240 are coterminal with 120. So again, it means they have the same initial and terminal sides. We can do the same thing using radian measures. So let's go ahead and do a radian measure of 7 pi over 6. So if you don't know where that is, you could take 7 pi over 6 and multiply it by 180 over pi to get our degree measure, which is 210 degrees, which tells me that this is in quadrant 3. So that means my graph would start here and go here. So that's 7 pi over 6, or 210 degrees. So if I want to find a positive coterminal measure, I have to go all the way around another 360, or because we're in radians, 2 pi. So that means if I want to add these two together, I need to get a common denominator, which would be multiplying this fraction that's over 1 by 6 over 6. So when I do, I get 7 pi over 6 plus 6 times 2 pi would give me 12 pi over 6, which means that gives me 19 pi over 6. So if I draw the same terminal side and go all the way around my circle and stop here, that gives me 19 pi over 6, which is coterminal with 7 pi over 6. If I want a negative coterminal answer, 7 pi over 6, I subtract 2 pi instead, which again means you need to multiply this by 6 over 6 to get a common denominator. So when you do that, you get 7 pi over 6 minus 12 pi over 6, which gives us negative 5 pi over 6. So that would be a negative coterminal measure. So again, we still have the same initial and terminal side, but instead we're going clockwise on our circle. So negative 5 pi over 6 is coterminal with 7 pi over 6, which is also, of course, coterminal to 19 pi over 6. We could, of course, keep adding or subtracting 2 pi, so there are infinite possible answers that you could have here. So go ahead and do these bottom problems 5 through 10 on your own. Find 2 coterminal angles, do one positive measure and one negative measure, and then when you're done, unpause the video and we will look at our work. So if I look at the first one, if I add 360 degrees, because we're using degrees here, we get 433 degrees. That would be a positive answer. If I took 73 degrees and subtracted 360 degrees, I would get negative 287 degrees, which would give me a negative coterminal answer. Negative 46, if I add 360 degrees to that, I get 314, which is coterminal. If I take negative 46 degrees and subtract 360 degrees, I get negative 406 degrees. So those are all coterminal. 312, if I add 360 degrees, I get 672 degrees. If I take 312 degrees and subtract 360 degrees, I get negative 48 degrees. And again, when you are using radian measures, and how do I know 8, 9, and 10 are radians? Because they don't have a degree symbol, we are going to add and subtract 2 pi. So if I add 2 pi here, I need a common denominator, which means I need to multiply this by 7 over 7. So I get pi over 7 plus 14 pi over 7, which gives me 15 pi over 7. And then if I take pi over 7 and subtract 2 pi, again, you need to get a common denominator. So pi over 7 minus 14 pi over 7 gives me negative 13 pi over 7. For the next one, when we add 2 pi, we get negative 2 pi over 3. For your common denominator, multiply this by 3 over 3. So negative 2 pi over 3 plus 6 pi over 3, and negative 2 pi over 3 minus 6 pi over 3 would give you a positive and negative. So that gives us 4 pi over 3 and negative 8 pi over 3 for our coterminal angle measures. And same thing here, you would add and subtract 2 pi. So if I add 2 pi, I get need to multiply this by 3 over 3. So really you're adding 6 pi over 3. So that gives us 23 pi over 3. And if I do the negative angle measurements, I have 17 pi over 3 minus 6 pi over 3. Notice when I do that, that still gives me a positive angle measurement, 11 pi over 3, which I can use for a coterminal answer that's positive, but I still need a negative one, so I subtract another 6 pi over 3, which gives me 5 pi over 3, which is also coterminal. So if I still want to get a negative angle measurement, I need to subtract another 6 pi over 3, which gives me negative pi over 3. So this would be my negative answer. So I could have used any one of those positive for the positive answer. And then this one would be a negative one. And of course, I could keep subtracting 6 pi over 3 to get another negative solution. And that's it for our coterminal angles.